there is something might be interesting. So I hope they will enjoy it. And this is the same, it will be in the class also.
Okay, great, great.
Okay, should we start or wait?
Just wait like
okay.
another 4
minutes.
minutes. Okay. Yes, 4 or 5 minutes.
Perfect.
Because we have some people who okay, so we're good. So we are streaming live right now. I just want to just a second, just get this right. Okay. Right. So as more people join us, they will get to second. Okay. All right. Okay, so we'll have 3 minutes to go by my time. I won't believe that quite a number of people have started joining already. Yep. Okay, just some housekeeping to ensure that all right, so I think we're gonna go live right now. It's time. So good afternoon, good morning, good evening, wherever you are and what part of the world you are. I don't know what the time zone is, but you're welcome to Integrated MLAI's special session with Thom. It's called Getting Started with Data Science with Thom Ives. And I'm sure a lot of you are going to be wondering, oh, where's Thom? Where's Thom? Okay, Thom had to make a very urgent trip to some other part of the country, but cell service is very poor where he is. He's going to join us. I'm sure he's trying to join us right now, but cell reception is very poor. All right. So because of that, we got one of our very own, our very, very great friends. Now I'm going to give you a secret. And the secret is this. When I did that blog post on LinkedIn, I'm talking about that Thom has a secret that's going to make you very, very, very successful data scientist. Now, this is the secret. So Thom and this wonderful man you're seeing right here on your screen are writing a book together. This is the part where you shout, yay! And the book is really amazing. I've gotten a glimpse of what the content of the book is, all right? But trust me, a lot is going into that book, and it's like you have never seen a book on data science like that, all right? So because Thom is not here personally to he's not able to join us, or maybe he will join us if his cell reception allows him to. We have just thought, okay, who is the best person to stand in for Thom, you know, when Thom is not around, and who else other than the co-author of that amazing book. And I'm talking about amazing because, I mean, you need to see the book, all right? So, but I'm sure they're going to give us some early access, you know, maybe they're going to make it open soon, like an early access program, just for you to get a feel of what the book contains. But trust me, it's amazing. It's amazing, all right? So who am I talking about? His name is Ghaith Sankari. He is my big brother, and he's amazing in many ways. He is Guy. Should I introduce you, or you want to introduce yourself?
No. I think what you did great, more than expected. Thank you. I'm only one of the family at that. Now, I agree with you on one thing. That book is amazing, not because we are authoring it. It's because it's, let's say, we get the feedback from the family and from our job and from our experience and from other experience. So at the end, we are trying to create a real experience for who's reading this book. So it's amazing, not because of the authors, it's because our field is amazing. Let me say it like this. Since Thom is not here, he messaged me and he's telling hi to everyone. He's with us and he will be with us always. Plus, the secret is more deeper than that. I think it's not only we are co-authoring together, me and Thom, we are brothers. I'm honored with this brotherhood, with him, with you, with all the family members. I will go directly to the to our session today. And our session is also part of the book at the end somehow. That means for sure it's not the same content, but this is the same ideas that we are trying to show in the book. So I will share my screen to have more discussion. Hugo, please just if there is any urgent question or something, you have to notify me, because once I share my screen, I'm unable to manage everything. I'm using one screen only.
I'll do that. I'll do just that.
Okay. Since the last session, it was focusing on the model selection for regression tasks. So this session, it will be going to the side of classification tasks and how to select the model for the classification. But I decided not to go into code immediately, just to create kind of conceptual mindset for us all, to go next week to the code and explain what we are able to do with this. So the target, I'm just, if everybody here or somebody is just aware about the statement from Dennis Rothman that always it's AI or machine learning or data science, at the end, it's a kind of mindset. What we mean by that, for sure, there is a lot of mathematical work, there is a lot of mathematical evidence, mathematical proofing, but at the end, it's mindset. Even when we are talking about regression task or classification task, this, let's say, categorization, it's also a mindset. I will give a small example before going to the slides more. For example, when we have to make a decision between doing or not doing something, this is the classification in general. And at the end, it's our decision, but it's built on what? It's built on a lot of, let's say, features, a lot of concepts that we are looking for, a lot of settings we have to consider. And according to that, we have a probability and we make the decision with the most successful probability. exactly, this is how we are able to move from regression in general and transfer this regression values somehow, sometimes to probabilities, which is a value between 0 and 1, and then make threshold to make a decision, which is it's moved into classification. So the classification as a task, it's a mindset at the end, and we have to find the suitable mathematical way and then programmatical way, or let's say automated way to implement this classification. Now, saying that, we have to consider just a little bit 2-3 fundamental questions. Always we are talking, whenever we are talking about systems, not only machine learning systems, we are talking about input goes to the model and then there is an output. Now, this model, it might be the environment that we are living in. It might be our bodies. It might be a computer model. That means software, application, which is it has inside its own workflow or flowchart or something. And it might be a machine learning model. The question that we have to think about, what is inside the model that we name it, inside the box? What's happened inside that? For our session, this is general question for sure. For our session, what is the classification? We have to know exactly what we mean by classification. And what is the regression, which is already we explained. And always, this is the essential question in all machine learning. What will happen if we change the input? So whatever we are going to discuss today, always keep this 3 questions in mind, please, because this three question, it will always tell us what is the best way to go through our tasks. Some of the information we are going to show today, it might be very basic or very essential, but at the end, I found it good before going to the code immediately to spend this week explaining about these concepts and how this classification models or algorithms appeared and from where it comes. Let's go to the first. What is the classification? Classification, it's statistical concept. That means when we are facing a problem that we have to set a categories for a population. Now, I want to here just to highlight the difference between classification and regression, because the regression, it's more dealing with continuous value. When we are trying to find a regression model, that means we are trying to find always output to a related inputs. So we are not looking for a special kind of clustering or classifying the output or the population into classes. Now, at the end, classification from this point of view, no, it's trying to create a kind of differentiation between the population clusters for a reason, because each cluster, it might lead to different another action or more modeling needed according to that. So that's why I'm telling you in the beginning, at the end, classification, even if it's statistical, and right now it's reflected to our machine learning, but also its mindset. That means whatever it was, the classes that we are looking for, maybe if we ask 2 people from the same domain about the classes that they are looking for their problems, each person will give different identification for the classes. So thanks for data and for the data generated in our age that help us to create kind of similarity for our classes. So according to that, we can provide more evidences to these experts toward which kind of classification classes they have to consider. So for example, I will go for one example. If we are talking about a patient with a set of inputs and we are looking for a class that he is diabetes, for example, he has diabetes type 1 or diabetes type 2. Maybe if we use the expert experiments only, we might find different inputs they are looking for. And maybe both of them, they will be okay. But when we are using our data, maybe we will have more related inputs to decide which kind of diabetes it will be there. This is for sure, it's rough example. At the end, I'm not a physician to make a clear example about that. So at the end, classification, it's mindset, but it's supported with data and data algorithm processing algorithms to create a kind of unified classes toward a unified problems, for example. There is a multiple methods to perform classification in machine learning. Today, I will just focus on some methods. I will talk about decision trees, then random forest, then what is the difference between random forest and boosting algorithms, and then the high level about neural networks. How to use these techniques, these methods to perform classification tasks. For sure, there is other methods, but this is somehow lay into a supervised learning. So that's why I will focus on it, since even most of our tasks that we are looking for, it's focused on the supervised learning. Beside that, let's start why I want to start from the decision trees, because what I added into the two parents here, which is it's Boolean-based classifier. Yes. Hello?
Okay, I think that was an error. I'm just going to go ahead and disable that right now.
So I can continue, okay?
Right, yeah, go ahead, please.
Okay, so I name it the Boolean-based classifiers. Why it's Boolean-based? What's the mean? I think we know, we always hear about linear algebra, and there's also Boolean algebra. Boolean algebra, which is deal with the 0 or 1, which is deal with the decision yes or no always. Now, according to that decision trees, it's doing the same. When we are facing the decision tree, let's start from this image on the left. We always start from first condition. We are testing it. And according to that, when we move to the second part, to the second level, we are adding more tests. And according to the yes or no, at the end, we will reach to a decision according to that. Now, how the decision tree will be trained, honestly, we will have a data set, and then we will train the decision tree according to this data set. And most of the time, decision tree will perform great for the data set, for the training set. But we always, according to this understanding for the decision trees, we always we are not sure if the decision tree will perform well with the production data or with outside of training data sets. Why? Because it's very overfitting toward the data set. But at the end, if you have a since we are talking about the data set as sample from the general population, if it's generated in sufficient statistical way, at the end, we are in a place that maybe decision trees can do the good work for us. Now, the second image here, which is in the middle, it will show us how the decision tree it works and how it's classify or find the classes in our data sets according to our input. Now, honestly, each level of the tree, which is shown here, it's creating kind of linear relationship between the input and the output. Now, with mixing all of this, we can find that we have a grid of linear relationships, and this grid, it decides the classes. So it's not expected at all to find non-linear, let's say, relationship detected with decision trees. But with decision trees, we are expected to have a very detailed nested linear relationships. That's why somehow it will work very well toward classification tasks. And it will use because it's also easy to be trained and easy to be explained also. Now, just this is from the history. I will go to this part, which is how to build in a simple way a decision tree. That means not using scikit-learn or any other library or framework provided to us, TensorFlow or PyTorch. Just as an idea, we have a data set and we want to create a decision tree for this data set. For example, one of these fields, maybe the year or maybe the abstract or any kind of the fields in our CSV file can be the label. And then we want to create a decision tree to classify our books, for example. Simply, it's start from sorting the columns, the features. And honestly, how it will be sorted, for sure, we need encoding. We need to change these values into numbers when it's needed by maybe one-hot encoding or ordinal encoding. All of these tricks that you can find it in our videos, in the family videos, we are explaining it in detailed way. Also with the class, the automated machine learning class, you can find all of this for the encoding. But after the encoding, once we have a data set, and we need to try to implement decision tree, and we don't have a library, we want to create it from scratch. Honestly, it's started from finding which column or which value, which feature has the most sparse values. That means that has the most distinct number of values inside it, regardless the repeated. And then we will sort this from higher to lower or from lower to higher according to that. And then we will move, and for each value in this column, we will try to perform the second column until we reach to the labels. Once we perform this sorting for all the columns in our CSV file, it will be a task of maybe SQL statement, maybe a task of any kind of algorithm to select exactly how to go through these values in a simple way, in a fast way, to find the suitable label or to find your class that you are looking for. So building the decision tree itself, even if we don't have, this is exactly what's happened when we are training decision tree against one data set. It's like this, it's built on sorting. Now, why I'm mentioning that, for sure, but by the way, maybe in the early ages, let's say in 2004, it was exercise for me in the college just to build a training model, how to train decision tree, regardless what is the input it will be. That means it was early stage for us to build kind of automated method to train decision trees. But why I'm mentioning that right now, in this very moment, because I want to highlight what I said in the beginning. At the end, it's a mindset. Right now, we give it a name, we make it a model, and we give it a training. And then according to the training, we have then the accuracy and all of these matrices. Yes, perfect. It's how framed right now. But what is the decision tree? It starts from sorting algorithms, which is something all of us study it when we are studying algorithmic coding, for example. So when we understand the concept, it will be easy to understand which model we are looking for example. As insight, at the end, it's better to try whatever you are able to try it. But you can expect that this task, it can be solved with decision trees. But as we mentioned in the beginning, decision trees, it has some limitation, which is mainly I will mention two limitations here. First, we are in danger of overfitting against the training set, because it will perform great in the training set, but it will not be that much great, maybe not be that much great with the outside data, that means data outside of the training set, because it's very much able to be overfitted. Hugo, just I have one notice here. I found 3 messages in the chat, so I will check them to continue with the random forest after that.
I've checked the messages. I've responded to them.
Okay. That means there is no questions.
No, not a question. Yeah.
Okay. Now, from decision trees, we have this chance. The first limitation is the overfitting. The second limitation, we don't have a clear clue about which feature or which column is the most important. That means where to start our conditioning, where to start our, let's say, questions that we are challenging the decision tree against it. From which column, from which feature, okay? So, and this might change the classification performance according to that. To solve this issue, we go to the, let's say, more deeper case, which is the random forest. Now, the random forest, it's creating n number of decision trees. By the way, decision trees also it's named usually as binary trees, because as I told you, it's Boolean algebra based classifiers. For sure, it can be used also for the regression. So that's why it's called as a binary trees. But we know that when we use a lot of binary conditions, we can define something non-binary, or we can perform classification for multi-classes, not only binary classification. So in the random forest, we are in, let's say, expanding the concept of the decision tree to go through multiple trees, n tree, against our dataset. Each tree will give us a result, and then we will find what is kind of only averaging, or kind of, let's say, what is the majority of the results it will look like. So we consider this majority as a final result. Again, let's consider that we want to test if the patient is at risk for the heart attack or not. We have 3-4 features, for example, which is the age, blood pressure, and cholesterol values, the both cholesterol, good cholesterol and bad cholesterol values. This is our features, and we want to create a decision tree according to our data set, that if he is really in risk to have a heart attack or not. So we started with the age, for example, in the first tree, but in the second tree we start from the cholesterol. For the third tree we start from blood pressure, and then we run all of this together to find what is the decision against our data set. And then the final decision, it will be the majority of the decisions coming from all the trees. Now, what is the value here? For example, at the end, when we are talking about our situation, maybe 3 of the 5 trees that we are suggesting, the random forest, tell us that this patient in risk. So we will make the final decision that this patient in risk. And then this will be the value that will be used to train against it. That means we'll check if really he is in risk or not, according to we are talking about supervised learning scenario. So this is mainly the decision tree. How it works on n count, the random forest, it works against n number of decision trees in parallel, and then it's averaging, majority voting to find the final results, and then this final result it will use to retrain the model. Now, okay, random forest, not random tree. Okay, I'm reading the chat again. Again, why it's random forest? Why, from where it's coming as a forest? Because we are using multiple numbers of decision tree. How to define the n? It is it's hyperparameter. We have to check it. That means we will check it next week with the code. It's a bunch of decision tree that start from different points. Yes, I can agree with you, Karim, on that. Yes, exactly. So we know that we have multiple features. So according to that, which feature it will be our first decision making, our first condition to test about. For example, back again to the blood pressure. Blood pressure, we know that the normal blood pressure, we have some definition from the domain experts. The normal blood pressure, systolic blood pressure, is 12 or 120. For example, the first test we are going to make, if the blood pressure is over 120 at this time for this patient or less. Now, this is the first tree, for example. Now, when we move to the second tree, we are not going to start from the blood pressure. We'll start from the cholesterol values and so on. And for the third, for example, we will start from the age. Each starting point and the combinations, it will give us a new tree, totally different decision tree. Now, how to find the final result? It's just only majority voting or averaging the values coming from the tree. For sure, in classification, it will be majority voting. For the regression, it will be averaging. Okay, so since we are talking about classification, it will be the majority voting. The entire trees are working together. It's giving the results, no affection for the results against each other. At the end, we are trying to make a majority voting. And this is why it's some of the software engineers, they name it if-else trees. Some I prefer to name it as Boolean-based classifiers. Okay. Now this is the random forest. Now how we are differentiate? We know that the boosting method, just like AdaBoost or XGBoost, it's also tree-based models. Okay. But what is the major difference between the boosting and the random forest? Mainly, it's what we name it. It's the difference between bagging and boosting. Random forest, it's considered as a bagging for the multiple trees working in parallel and then performing majority voting. In the boosting, the output of the tree itself, of each tree, it will play major role to affect the next and the next trees. And at the end, the model will learn also from the output of the trees itself. It's weighted base, because each tree, it will has a weight, and how to train the model by also modifying the weight, because we want to understand which tree is doing worst in general and which tree is doing best. So it's, let's say, complicating the decision tree into more sophisticated way to have more, let's say, better statistical way to perform the task that we are looking for. So mainly, but the boosting, the main difference, it's not working in parallel and make majority voting. No, the decision trees itself, each decision tree, it will consider as input for the next decision tree, and the output, it will be the final one, which is considered the, let's say, that branch of trees, but it's performed beside all the weights coming from other trees. So that's why it's not Boolean based somehow. It's a mix between the weighted methods, which is similar to what we have in logistic regression, for example, and the Boolean based. And that's why most of the time boosting, it's able to be generalized more. That means it will perform better against data sets outside of the training data set, because it has two levels of training. So this is the second or the third part of classifier that we are going to face in the future, which is next week. We will have one data set and we will run all of these models, starting from decision trees until the neural networks, and we will compare. And if we have a time also, we might find a small conceptual place for to discuss about the deep learning, how deep learning different from general machine learning situation. It's a branch of it. So, okay, could random forest also used for regression problems? For sure. And it seems like it should be have a problem with the series data. Random forest, it's not working with a series, let's name it. How to use the random forest for the regression, and even, by the way, the boosting, it can be used for the regression. At the end, the regression, it's finding the output against one input. If the output that we are looking for, it's kind of a probability, and we have data that have this probability coming from, for example, from expert or something, we can train our model to give this, even if it's look like it's giving classes, yes, no, but at the end, it can find a value at that, okay? So it can be work as a regressor, but it's the major difference, it's how to find the final value, which is, it's not using the majority voting, it's using the average. The final value in the random forest will be the average. Okay, thank you, Karim. Now, the third, the final thing that we will try to discuss about it, it is today, and then we'll be open for question and comments from your side. It's the classification according to the neural networks. Sorry for that, I was looking for the watch, for the, what's the time. So neural networks at the end, it's different from the decision trees and the tree-based models, because it's not a kind of Boolean, it's linear algebra, more linear algebra, but it has multiple processing or mathematic units, which is, we name it the neurons. Now, at the end, to have it as a classifier, we need to use the sigmoid function as activation function, because sigmoid, it's returning a value from between 0 and 1. It can consider as probability, and with the suggested, with a good way to suggest the threshold, we can find what is the classes that we are looking for. For sure, in classification in general, this is a conceptual session, as I told you, just to know how each one it's working, what is the tree, what is the decision tree, how it's built in the beginning, and how it's trained in the beginning before having these frameworks, and then how to move from decision tree to random forest to the boost methods, and how this tree-based method, let's say, differentiated from the neural networks, and also how sometimes they have kind of similarity, because neural networks, it's also weighted based. This is how we can find it similar to the boost method. So sigmoid function, it will give us probability. With the suggested threshold, we can find the decision, we can find the classes that we are looking for to perform the classification. So next week, since right now it's 4:30, 4:30 my time, sorry. Next week, we will have one data set, and we will go to find binary classification, not multi-class classification, binary classification against decision tree, random forest, XGBoost, and assemble neural networks. And if we have a chance, we might go for a deep learning scenario. But deep learning scenario, it will need a bigger data set, so hopefully we can find it at that. This is the session for today. It's just to build the concepts, to define what is the classification, and how all of these models are built. One last thing I want to mention, which is very important. In the regression, always we are looking for the distribution of our data set. And the most probably desired distribution, or which is, we name it as assumption, which is not a requirement, but it's assumption for the linear regression, for example, that most of the features has to be distributed as natural distribution. Now, in the classification, we are dealing with different case. We need to raise the sensitivity of our model, especially when we are using neural networks, toward both classes or the classes that we have. So in this case, natural distribution for the features and for the labels, it will not be desired. The most important is to have uniform distribution for the labels, to be sure that all the classes are covered, and the training it will perform, it will have the same weights, especially with the weighted based models, the same weight toward all the classes that we are looking for. One also last thing I just noticed right now, which is here there is a mistake. Binary classification, that means it's 0 or 1. With two nodes in the output layers, you are not performing binary classification. We have multi-class classification. So the binary classification, most probably we will have one node, one output, one node in the output layer only. So this is our session for today. Open for your question, and thank you for being patient.
Thank you very much, Guy. This is enlightening, amazing. Okay, so the floor is open for questions. Right now, you can unmute yourselves. If you want to ask a question, you can raise your hand, unmute yourself, and ask a question into the microphone. So I'm just going to be looking out for the chat too, just in case somebody's, maybe your environment is noisy and you want to just type it in the chat. Okay, so guys, I think there's a question in the chat. Are logistics regression and nearest neighbor also class-based algorithms? Like, are they classification algorithms or?
Logistic regression, for sure, it can be used for classification by using the threshold at the end for the output. Nearest neighborhood, for sure, it's classification, but it's the main difference in nearest neighborhood. It's unsupervised learning, but it's used clustering, and at the end, each cluster, it can be considered as class. So yes, it can be considered as classification.
Okay, great. So, guys, there's somebody has like asked me one time that in a real organization, in a big organization, like an ideal organization where everything is structured the way it should be, does the data scientist need to know all of these, as in the whole machine learning end-to-end pipeline and all that? I mean, the data scientist should just tell the machine learning person, hey, I want you to do this. I want you to, this is how I think we should analyze this data, use decision trees and or use a random forest or use k-nearest neighbors or whatever, so that we can arrive at this. And then the machine learning engineer just goes to execute. Is that correct? Is that how it happens in real life?
Okay, real life, it's you start your question from the big organizations. Okay, but real life, it has big and small organizations. Let me tell you the following. What is the major difference, let's say, we can consider between a startup, even very small scale startup, and medium sized startup, and then the big organizations? The major difference is the startup, it's running behind a predefined idea. They know what they want to do and how to do it. And then there is kind of, for sure, this idea has to be innovative to have a place in the market. In the big organizations, they have a very structured way for decision making. And according to that, honestly, what you get from the big organization, it's the management skills more than the technical skills. So in the big organization, no, it will not be that everyone is knowing everything. It will be everyone is doing his task. And this speciality spread it between the team with the perfect management model that get the insights from all the teams, for example, not only data science, for example, there is other teams might be there. The management model, it will perform the magic here. And again, I agree with Dennis Rothman again, because I was always highlighting this point and he make a post about it maybe last week. Yes, when you are talking about, for example, project management and more than that, sometimes it's not only project management, it starts from project management, but it can go deeper to, let's say, more researcher work to go to the production and all of this together. This is not something technical to be performed, but it's giving a space for each team member to perform his task in the correct way. For sure, there is someone which is maybe not that much strong technically. That means he is not performing the coding by himself, but he understands the concepts and he can decide. And according to that, there is this great people who is able to perform his vision and tell him that this is works and this is not works, to find another way to go through it. So when we are talking about big organizations, this is the good thing, that you are driven by the results. With a startup, you are driven by the innovation somehow. And that's why you can find there is a lot of big organizations, they are acquiring startups because the startup is showing something unique and they are able to scale it up.
Okay, great. So before we go to the question in the chat, I've heard some people also say, like, it's better to get a job at a startup if you're starting out as a data scientist than to get a job in the big tech, basically. So what's your view on this?
Sorry, I didn't get it. I lose the voice for a while, so please.
Okay, so some people have said that it's better to start your data science career in a startup than in big tech like Amazon and co. Is this correct? What do you think of it?
It's also not easy to answer this. At the end, okay. Let me tell you something. We are 7 billion person living on this planet. Now the data science community all over the world, it's going bigger and bigger. There's great things that data scientists are performing, and this is why it's more attractive to the new skills, to the new generation, let's name it. Okay, I agree on all of this. But where to start? I think there is a 7 billion lane to follow in general. But I will go through the following. the big organization or the fantastic, the mega huge organization like Amazon, Google, others, I don't want to mention the name that I work for, you can find it on LinkedIn. All of them, they have this intern programs, they are supporting this intern, and most of these people, they are maybe end up working for the same company after finishing their study as a data scientist. So for example, this is one lane, and this is considerable great lane. And at the end, they will work on the great organization, and they will get the salary that they are looking for, and let's say the growth path that they are looking for. Now, on the other hand, is it final? This is the only lane? No, it's great to start with the startup and find the innovation that you are looking for, serve a new market, new business idea. At the end, this is our algorithms, our space coverage, it's limited. We know this is, when we are talking about machine learning, we know that we have reinforcement learning, supervised, unsupervised learning. With all these trees that you can find, at the end, it's one of these. When we are talking about data science, we have the prediction modeling and the analytic modeling. The analytic modeling, they have the statistical model, and we have other models that we are able to follow. The space is limited. It's not easy to cover it as one person, but the idea for the startups, it's from the business that you are serving itself. So if you want to start with the startup, find the interesting startup for you and work for them at that point, for sure, when it's possible. And after that, maybe your work for that startup, it will open the doors for you for the big organization when you are looking for, or it will open the door for your own business also, which is the third lane. It's always available, but for sure, be careful about deciding about that before deciding about having your own business, because at that point, you have to find again what is the business model for you, and to be sure that you are in the market in a correct way. So at the end, I cannot say that this is better, starting from startup is better, or starting from the big organization, big companies is better. I cannot find this. Honestly, I will speak from my experience. I was up and down. My career started in the startup in Syria. Then I moved to the great chain of hospitals, which is right now, it's one of the, let's say, the biggest 4 chain of hospitals in the world, which is Mediclinic. I worked for them for 5 years. Then I go again and make my own startup in UAE. I worked for it for another 3 years. Right now, I'm back again to bigger organization related, all of my life related to the healthcare. So at the end, if you want to take it from my life, it's up and down. Up and down, that means startup, big organization, startup, big organization. I don't know what will happen in the future, but I'm happy right now here. So there is no unique lane that we are telling that everybody has to go there. I think that this algorithms that I think it's named Ant algorithm. Ant algorithm is not working here. Each person, according to his personal life, to his situation, has to decide about his path. Not only him, also sometimes the community is forcing him to follow someone. At the end, look for your passion. You have to be happy with what you are doing. If you are not happy, it will never be a success story.
Right. Okay, so let's look at the question in the chat before we come back to this. Okay, so
neural
this
network,
question, yeah. Okay,
yes.
Go ahead.
Karim, again. Neural network versus deep neural networks is comparable to how decision tree is to random forest. Going from one tree or network to many. Deep neural networks, if you want to consider it like this, somehow it can do that. But the main difference, it's say the great about deep neural network, it's not only moving from one decision tree to others, it's moving from linear to non-linear relationship that can be detected. And by building over the, let's say, a lot of linear relationships, that mean finding the suitable points. Now, this is the great about deep neural networks. Now, but it's cost a lot. That's why I agree somehow on the expansion that you mentioned from decision tree to the random forest, but still random forest is unable to build or to detect nonlinear relationship, according to my knowledge. Here I'm thinking while I'm answering, because this statement you said, it's great. I like it, but we have to consider this, moving from linear to nonlinear relationships.
Okay, Guy, thank you. So while we wait for another question to come in, what do you think is like the most important tool set for the data scientist? What would you
You mean
think
by
if
tool
someone,
set?
yes, if somebody tells you I want to be a data scientist today right now, what's the first advice you're going to give the person?
Be tool agnostic.
Okay.
Okay. No, I'm not fooling you. I'm talking in again, this is from Tom, from Dennis, from all the great mentors that I face in my life. Master the basics, master the concepts, understand the mathematics, the statistic, the linear algebra and Boolean algebra behind these models. Once you master this, you are able to use any tool sets that you want. Beside that, okay, yes, Karim, I will post it. Beside that, also master the, let's say, the logical, let's name it logical thinking. There's something called logical programming, and it was great, but the main problem with the logical programming, it was very slow programming languages. Now, yes, let's say master the logical growth that you are looking for. I mean that there is no limit for your hope, but the limit, it's about the steps. Always think about this logical available steps to reach to the impossible. There's no limit to where you are able to reach. So this is what I'm able to say right now. Master the concepts. I know one person, he's a great person, he's from Poland. One friend, until this moment, when he want to design a model, he used the paper and pen, starting from paper and pen. And he's great, he's doing great. Each model is, let's say, state of art for him. He's not in the production level, he's in the, let's say, research or vertical growth level, we name it me and Tom. But each model he is building, it's state of art really. So yes, master the basics, and the mathematics, it's considered a unified language, so that's why. So this is what I can say in the beginning. For sure, the second step, don't ignore Python. You cannot ignore it. By the way, I learned Python very late in my career life. Previously, I was more related to the object-oriented programming, just like Java, C++, and C# after that. But at the end, I found myself, no, I have to go toward Python. When you understand Python, there's previously also some language like Lisp, which is currently is not used, or only it has a framework in MATLAB. But there's a new programming language right now. It's, I think, 4 years, a bit before 4 years. It's called Julia. Julia, it has the simplicity of Python with the structure of Lisp to perform the data science tasks. And it has the speed of C++. It's a great tool. But before going to Julia, I can say first, master Python. I'm not going to mention any frameworks related. For example, please, nobody ask me if TensorFlow better or PyTorch. I'm not going to answer this. I'm tool agnostic from this point of view, even if I'm working with TensorFlow. But honestly, I cannot tell that which one is better. I don't believe there's one is the better. The better is the mentality behind it, the person who is designing all of this. AutoML. Okay, AutoML, previously I was again, Karim. What are Hugo? Just can I ask you for this, because once I'm talking, we only have 10 minutes to move to the class. If
Okay.
it's possible to post my LinkedIn account in the chat for everyone.
I'll do just that right away.
Okay. Now, what is my view about AutoML? AutoML, previously I was in an event related to the AutoML, and I was telling the people that it's a must. But why it's a must? It's not a must to build your model that it will go to the production. It's a must because it's make your life easier. It's give you the possibility to use high cost resources, for example, to test which model it will help you. Now, AutoML, I think until now, most of the AutoML studios are, let's name it studios as a concept right now, are focusing on the model selection, but still you have to perform your data preparation task by yourself. Okay, so according to that, Python and Julia tools made life easier. Yes, somehow I can say that. But for the AutoML, it's back to the AutoML. So according to that, you have to consider it when you are planning to make a business model, something it will be used on the business data science or machine learning model that will be used in business, because the time is playing major role there. And also it has another great benefit. It can be used by non-technical people. That mean like business analysts or domain experts somehow, to test at least the possibility. For sure, it will not give you currently, it might not give you the final model that you are looking for. You need to tune more hyperparameters. You need to work more on the also retraining path. But at the end, it will give you great start. Now, Python and Julia, you know why Python, everybody is focusing on it right now. Julia, it's having the same possibilities, but the structure behind Julia is very great. But until now, Julia, it's downrated, underrated. That means in the market, there's no clear request for Julia, even if I find it great. But why I'm telling you be tool agnostic? Because, for example, in many, even big organizations, they are looking for what's the result you are able to perform, not about the tool that you are able to use. The tool, it's playing major role for medium and small companies, because they are always, let's say, because I was working for one and I have one, always the deadline is very near, always. So that means they want somebody to add the value immediately to their work.
Okay, great. So is there any other question that we need to attend to? Okay, I think there is. All right. So guys, from my end, one more thing.
Yeah.
What is the right path to becoming a full scientist?
I lose
Some people say, I said, what's the right path to become a full, well-rounded data scientist? Some people think that you should first become an analyst, and then when you're done with the data analysis, you can now progress into some more deep learning, machine learning, and then all of that. Some people, yes, please.
Don't take it as, let's say, criticism. It's not criticism.
Right.
Okay, but I will say something that you might find it not good, but I think if you think about it, it will be good. You are more political person than technical person somehow. Okay.
No, I have a lot of mentees. I get involved in a lot of mentoring, so
that's great.
I get to get these questions, and I'm now asking. Yeah, it's just for fun. I'm just asking guys now, how would you answer such a question? Because I'm also learning how to answer and respond to some of those questions. So, how do you answer such a question? Somebody throws it to you.
I will tell you. Again, it's related. when I said previously, I will use my word. I will use also our friend Susan Welsh word. One time we are in the event and she said something. I'm not looking for success. I'm looking for happiness. And my word, I was telling you previously, look for your passion, work for what you are working, what you love for. Now, in both sides, I'm not mentioning the technical side. At the end, our value as a people, it's related to what we are giving to the community. We are working to live. We are working to get the income to pay our bills at the end, for sure. But also, on the long term, what we are giving to the community. So maybe the best path, it will be the teaching or mentoring for some people, because they are great on that. They are able to simplify the information and give it to the student, and the student can go from there and expand, and they will be great data scientists. So maybe the mentor himself, he will not be that much great in performing, but he is the best who can simplify the information, understand it and simplify it, and move this knowledge to the other. This is one way. The other path, it might be, which is my path. I like it a lot because at the end, all of our work, it's computerized, it's automated somehow. It's built over the software engineering. So I found the best one according to my experience. That means it's not final answer, but this is my life. It's going from software engineering with all the analytics, the business analytics needs for that, and then move to the data science. I think this will be successful one, most probably. But there's the other side. It's when you are data scientist, for example, working for the healthcare. In our organization where I'm working, again, I'm not going to mention the name, but part of the data science team, they are coming from pharmaceutical, for example, background, or from medical background. But right now they are data scientists. At the end, which task inside the team, it will be decided according to that. But there is no optimal scenario. It's the most important, what target you are serving. What is the target that you are serving? Now, for me, I feel the technical background, the software engineering background, it will be the best one, because also it will give you the power to decide when and where to use machine learning, for example, models, and when it will be more suitable to use, let's say, workflow decision making, which is not, let's say, traditional software engineering. Sometimes traditional software engineering can make very smart decisions. So this is the background. This is my background, and this is how I work. But it is the final? No, this is what I prefer. I will be happy if I met a person coming from software engineering background, data scientist coming from software engineering background.
All right.
Let's name this out of records, okay?
All right then. Thank you very much, guys.
Thank you. Okay. I think 2 minutes to move to the class. So
yes,
I think we have stopped here. The class, it will be the same. So who's involved in both, he can skip the class. Who's not, he can attend to the class.
All right, great. Thank you very much, guys. So I want to believe that everyone, since we didn't have any more questions, but if you still have any more questions for Ghaith, you can connect with him on LinkedIn, or you can send me a mail and I would reach out to him with your question. If you're not on the Slack group, I would say I probably am going to send an invitation to everyone in this meeting right now. You know, I'm going to send an invitation to everyone that came in for the meeting. So what I'm going to do is, when I send you that invitation, if you want to join the Slack group, yeah, you just accept the invite. But if you don't want, just ignore. All right. So, but I'm going to send the Slack invites to everyone. All right. So if you want to join, it's great. We'd love to welcome you. But just in case you don't want to, just ignore it. All right. So yeah. So thank you everyone for your time. Like I said, if you still want to reach out to Ghaith, you can do so via LinkedIn, or you could send us a mail, timezone.ai@gmail.com, and we'll be glad to respond to every inquiry that you have. So for today, till we meet next week, this is me saying thank you for showing up. Thank you for coming. I hope you found value in today's session. Thank you guys once again for being there
Thank you.
to
Thank you,
deputize for
everyone.
Thom.
And I ask you for next session to be with me also. I will ask Thom for that, just to go for with code examples about what we talk about today.
Right. Thank you very much, guys.
Thank you.
All right then. Bye, everyone.
Bye.
Bye.
Recording in progress.